So great to be back to Berlin again, and great to see so many of you here. We have a vibrant community of users building new things with Qt and the tools we offer. Creating a strong community and ecosystem has been our goal since almost 30 years. One important group is students who keep the community fresh. Qt has always been widely used in education, but we wanted to do more. And the Qt Academy and Qt Education license offering is growing rapidly. I'm really happy to be able to announce that students and teachers from over 2,000 universities globally have a Qt Education license today. Have students with Qt Education license today. More and more students identify Qt as an important technology to learn. In total, over 15,000 students have an active Edu license from these 2,000 universities, and many more are using the open source version of Qt in their studies, which is good. We want to offer, however, students also professional tools also for embedded development. Therefore, to strengthen our education collaboration, we are now adding the ability to develop for microcontroller-powered devices, available immediately. Not only the student community, also the overall Qt user community is constantly growing. As this chart for the past 5 years shows, the amount of users is increasing steadily, and we want to keep it that way. So as another announcement, we have decided to renew our offering for small businesses to further accelerate the growth of the Qt ecosystem. This is how it looks today. We have a lot of great startups and small businesses already using Qt, and we want to serve this segment even better. So starting next year, we will increase the company revenue limit to $1 million annual. We are adding professional technical support for the same price. This is under the same service level agreement as the full price licenses, with a limit of 5 support incidents per year. We make this faster and easier to purchase. We are replacing the eligibility pre-check done by the Qt company with a self-assessment web form. The price remains the same, just 450 euros per year. The renewed small business license is available in first quarter 2024. Qt Group portfolio optimizes the entire product creation pipeline. So let's now talk next a bit about the trends in the area of product creation. Software product creation requires multiple people, and in larger projects, multiple different teams to work together. As we all know, the pace of development is constantly increasing, and the complexity of the software is rapidly growing. The workflow has to be seamless between the different teams. These well-integrated tool chains increase the velocity in product creation. But information is often lost in handovers between these teams. The handovers can be improved, and the overhead should be minimized. A good example is the UI design to development, where we have managed to smoothen the handover from design tools such as Figma into QML code. To make the handover from Qt Design Studio to Qt Creator even better, we have been spending a lot of effort in the last months, and we will spend even more in the coming months. You can see some of these improvements already with the recent release of Qt Creator and the soon upcoming Design Studio release, and more will be coming in the beginning of next year in the releases of Creator and Design Studio. but we can make it even better. We believe in an open technology approach and in creating best-in-class products fit for purpose. Our open tools strategy has always allowed integration of our tools, such as the Qt Creator, into the product creation process. We have supported, since a long time, different compilers, build systems, version control systems, and enabled extending our tools with new functionality. But the next evolution of this strategy is something I'm truly excited of. Qt Creator will become an open platform as an IDE with a variety of new extensions. What does that mean? The objective of the platformization of the Qt Creator is to enable an ecosystem of plugins. As many of you know, Creator has had a plugin interfaces from the beginning. But while most features today are technically plugins, they are currently not easy to maintain outside of the Creator's release process. Not even for us, and even less for third parties at the moment. Therefore, we are currently investing into extending, harmonizing, and stabilizing the APIs of Qt Creator, ensuring that value created by others in the community is protected for a long time. This allows improvements to the extensions currently supported, but also integration of more value-adding capabilities, such as code assistance and code analysis tools. This will be available in 2024. The first visible steps will already be there with the next Creator release in April, and more to come then during next year. The open tool strategy is being implemented also in our QA portfolio. For example, Axivion Suite is already seamlessly integrated into different DevOps environments and IDEs. It has open APIs for creating rules, and many of our users are leveraging these to adjust the rules that we provide, or even for creating new rules according to their preferences for the Axivion Suite. Furthermore, we also embrace the open framework strategy. Our quality assurance tools work with C++, QML, and the Qt framework, but they also work well with other frameworks, especially for embedded devices. With Squish, the UI of hybrid applications that use some part of Qt and some with HTML or native frameworks can be tested. Axivion Suite supports testing also C and C#. So our tools on the quality assurance area are very well aligned with the open tools strategy of our company. Next, let's look into our open framework strategy. I'm inviting Volker on stage to tell you more about our work around this. Welcome.
Thank you, Tuukka. Great to be here. Great to see so many makers and creators and builders have come to Berlin this year to be part of our Qt community. I'm very much looking forward to talk to you about a topic that's very close to my heart, open framework strategy. When I started working on Qt in the early 2000s, one of the most important and most frequent questions we got asked in our Qt support team was basically this: Qt looks great. We would love to use Qt for our product, but we are using MFC. We are using Motif. How can I start using Qt without having to throw everything away, without having to rewrite everything? I can see that some of you can relate to that story. So we learned very early on that for Qt to be successful, we need to make it an open technology, an open framework that interoperates well with existing UI frameworks, with existing technologies. And we wouldn't be here, we wouldn't be where we are today with Qt if we wouldn't have built Qt as an open framework. If you think about your current project, did you start from scratch? Were you one of those lucky ones that started with an empty main CPP file? Or did you start from existing code? Maybe we can show some hands. How many of you are today working on a project where Qt is just one of many frameworks, one of many UI technologies that are working together? Let's see some hands. Okay, that's quite a few of you. And that's why I think this is such an exciting domain for us to work on the Qt project, enabling this use case, making this kind of solution possible for you to work with Qt together in an existing project. So this is not something that has to be a temporary hack. This is an example from the GE healthcare team. They are building a series of cardiovascular diagnostic devices where Qt is used together with native Windows technology. These are devices that are used in a safety-critical domain in the medical space, diagnosing patients in hospitals and clinics all over the world. What you're looking here is a Qt application running in a device that is otherwise built on native Windows. But it's also an application that can be used on a mobile device together with a handheld scanner. And it's an application where the same source code runs on a Windows desktop machine where the doctor can sit at his desk to do the diagnostics and measurements and analytics. So using Qt together with MFC, for instance, is not a migration tactics and it's not a short-term hack. It can be a very sound and sustainable technology strategy to combine different technologies with each other. If you had the free choice for your next project, would you insist that you can only use Qt for everything that you are doing? Or would you prefer a technology strategy where you can use the best of different things, the best of Qt, but also the best of native capabilities and the best of web capabilities? Now, of course, I'm biased. I would love if everything I'm using starts with a Q, because I know that then I get a consistent API, I get a well-designed API, I get an API that is cross-platform. I don't have to write my code 3 or 4 times to target all the different devices and form factors I want to target. And Qt does provide a lot of functionality. It's tempting to expect that everything we need to do to develop our application can come from Qt. And hopefully many of you are actually able to do that. Hopefully many of you are able to just use Qt and build your entire application. But sometimes it's good to be able to go native. It's good to be able to use other frameworks within your Qt project. There will always be other libraries, other frameworks, and platform services that your users would like you to use in your application. And we want to make it easy for you to use those components from those different frameworks. What you're looking at here is a fairly recent development, just a short video showing how to use Android native applications within a Qt Quick user interface. For this to work, we of course need to get the UI bits right. And arguably, one could easily build that Android UI with Qt Quick directly. Why embed some native framework, some native component? Well, your users might actually appreciate that you use the native component for certain things because it's well integrated into the native data storage as well. You get the alarms that you have set in your native alarm application or clock application. You get those also as part of your user interface. In Qt 6.7, which we are almost at the feature freeze for, we will have a newly architected activity view that allows us to blend native components from Android into Qt and the other way around. So like I mentioned, for this to work, we need to get the UI bits right, and we need to get this right on all platforms. You're expecting cross-platform solutions. But we also want to make it easy, and we also want to make it fun for you to mix these different technologies together. So here's an slightly more interesting example, perhaps. This is an example where we are using Qt Quick 3D for the 3D stuff, running in an Android application developed in Java. And the UI components that you're seeing are actually native Android UI components. So being able to use those parts of Qt that you find the most compelling for you in an application that has already been built with Android in this case, using Java, using Kotlin, having that capability to mix the different technologies together is really key to us making Qt available to a lot of people that would otherwise not be able to use it. So with Qt, you get a lot of these tools to be able to interface with a native framework, with a native programming environment, with a native language. Working with Java and C++, it's not always fun. We are trying to make it easier with some of the wrappers that we are building in Qt. And of course, you also should be able to use the native tools, like in this case, this application is developed with Android Studio. So we can't tell you, and we don't want to tell you what the right technology choice is, but we want to tell you that you do have the choice, both on the tooling side and on the framework side. One of the most popular UI technologies to bring together with a native Qt-based application is, of course, the web. And it has been possible for many years to consume web content inside of your Qt application, using Qt Web View, using Qt Web Engine. Typical use cases such as using your existing web-based authentication workflow, for instance, inside of your native application. It's a trade-off, as always. Maybe you want to support facial recognition or other biometric factors that require you to write this thing as a native flow, but maybe it's okay for you to use a web-based authentication flow. And now, over the last couple of years, we have invested a lot of research and a lot of development into making it possible with Qt for WebAssembly to also build web UIs using Qt. Building a native UI that your customers can access like a web page with a click on a URL. Launching a native application that runs at native performance in a secure sandboxed environment within your web browser without you having to deploy anything to your customers or to your end users. We're going to talk a bit more about that this afternoon in the roadmap presentation. I think WebAssembly has a lot of potential and is going to be a very exciting technology in the future. Now, of course, native applications, native frameworks, web, and so forth. Maybe for some of you, all of that is not very interesting. But I think there are two UI technologies in Qt that most of you are using, one of at least. And that's, of course, Qt Quick and Qt Widgets. And just like I said before, with MFC, we don't want you to throw away all the code that you have built. We don't want you to forget all the things that you know about Qt Widgets. We want you to feel that you have the choice. What is interesting in Qt Widgets, which is actively maintained, which continues to be maintained, which is not going to go away. Building your application with Qt Widgets, your existing code, and adding perhaps some of the things that are better and easier done with Qt Quick. Using QML instead of C++. Giving your designers some access to the user interface creation process. So you should be able to decide which UI technology fits your needs best for each part of your user experience. You can build new user interface components with Qt Quick, add them to your widget desktop application. Qt Quick widgets, Qt Quick widget in particular is something that is now part of the Qt 6 rendering stack. It's no longer tied to OpenGL. You can use the native rendering hardware infrastructure, Metal on Apple platforms, OpenGL on Linux, Direct3D on Windows, natively rendering Qt Quick controls and Qt Quick UI content into your widget application. And we also have now the RHI widget in case you want to drop down to actually low-level graphics programming inside of your widget user interface. Now, we know that there are quite a few sharp edges still. This is a complex problem. Many UI frameworks working together maybe many UI technologies working together. I would like to invite you to be part of that journey of making this better, helping us understand which use cases you have, which frameworks you're working together, what your expectations are. Look at how we are doing things in Qt. Qt is an open framework that is also open source. Have a look at how we are doing things. You will find out that we are also just cooking with water. We are not doing anything magic there. We are using native UIs, native APIs, native frameworks and technology together with Qt to build something that is hopefully easy to use and hopefully fun to use. If you're missing something, talk to us. Contribute something. You're all contributors to the Qt project, and some of you also with actual code patches to the upstream repository, but just your feedback is already a great contribution to us to make sure that we are going in the right direction. We are discovering every day how things are best done. Platforms evolve, Qt evolves, the languages that we are working with evolve, and hopefully we can make the next version of Qt always better than the previous one and make it a smooth experience for you to build your user interfaces. There is one trend, of course, that I was hoping could make all of this a bit easier. Recently, I was trying to figure out how to run or how to call Kotlin APIs from C++, and I figured somebody else has probably done this before, right? So I was looking around on Stack Overflow and so forth, trying to see if there is something I can get inspired by. And my last resort was to go to ChatGPT, asking like, okay, how do I actually implement this? How do I call this Kotlin function via J and I? I got an answer. I got lots of code back. That code didn't compile. The code didn't work. So instead of having to figure it out myself, I had to figure out someone else's code. And those of you who have been in the business for long enough know fixing someone else's code is not always a lot more fun. So one of the questions, of course, we are talking about trends in product creation is, with the advent of AI now, we can get more code thrown at us. But is it actually good code? Is it actually quality code? My sample size of 1 is maybe not qualifying me to answer this question, so I would like to ask my colleague Aleksina on stage from our QA team to talk about that exact question. Hello, Aleksina.
Thank you. Thank you, Volker. So does AI mean more quality? That's the question. Raise your hand if you think so. A few hands. So seems like I don't have a lot of convincing to do here. I might just probably go home at this point in time. No, kidding. So we all know how Gen AI increases the productivity in software development. It's easier and faster to create code with GitHub's Copilot, for instance. You create more code with less effort. But is more AI-generated code more quality? How do you actually know that the code you created meets your expectations? How do you know that the code used to train the LLM model now generated code that actually fits in your new context? How do you make sure that your application works as you wanted it in a functional way? We at Qt love the extra productivity that Gen AI brings, but we're also concerned about quality. We believe that the increasing amount of code, new code in the world, demands for more testing and for more automated testing. And to have a comprehensive quality assurance strategy, it's not enough to just automate your unit tests. You need to look at testing from a diverse viewpoint. You need to be able to automate your static code analysis, your UI functional testing, your architecture checks, and so forth. It's also not enough to just test more and automate testing. We also need to test earlier. In product creation, we just cannot wait until end of the project to start our testing. Quality assurance needs to be an integral part of the product development process. And we need to start finding issues early on in the project. Just imagine finding a flaw in your architecture at the very end of the project when you're about to release. And then going back, how difficult it is to fix that at that point in time, how costly it is, and how that would actually impact your time to market. Additionally, we need to get better at knowing what we've tested and what we haven't tested. And here, I would like to take the opportunity and announce our code coverage tool, Coco, Release 7.0, which introduces test data generation based on code coverage. You can easily increase your level of code coverage with less manual effort, again, allowing you to handle more code. Additionally, since at Qt, we have very deep knowledge about Qt framework and QML. In quality assurance, we're also able to provide a little bit more in these technologies. We're already providing QML lint, which is a very powerful linter, specifically designed for QML and finding QML recommendations. In the fall, we've been also working on some Qt-specific rules, including security rules in the Axivion suite, for any Qt development to develop even higher quality, secure code. And with these words, I would like to hand this back to Tuukka.
Thanks, Aleksina. Next, a bit about digital twins. A digital twin is a digital model of an actual real-world physical product, often beneficial in industrial automation, but also many other use cases. Digital twins serve as a digital counterpart of an existing physical item or an upcoming one, which might not even exist yet. The 3D capabilities of Qt framework and tooling help you in creating digital twins. We launched a new industrial automation demo showcasing the power of digital twins. The demo is available here in Berlin, now live and for you to see. But let's move forward on to our final topic of this speech, artificial intelligence. We already touched that a bit with the QA tools, and let's talk more about it before we end this presentation. So, generative AI, especially the emergence of the large language models and ChatGPT, has certainly been a disruptive technology, making AI interesting for the masses. Many things also outside of the software creation, but in this context that we are in, we are especially talking about what does it mean for software development and quality assurance. There are challenges, but certainly the generative AI presents also opportunities to accelerate the productivity of developers and quality engineers. But before talking about the potential of generative AI, let's first talk about how we position Qt related to AI in general. The generative AI and coding assistants have made great progress in recent months. There are already now many developers who have found generative AI useful in some of their work items. Sometimes generative AI can serve as a great peer programmer, as a virtual buddy to the programming work, or just reducing the work on boilerplate code and repetitive tasks. But the creativity and complexity of software programming will remain domains dominated by humans. Especially so software creation, what can be achieved is more towards augmented intelligence. That said, software companies and developers who don't tap into the artificial intelligence are certainly missing a good tool in their toolbox. The GitHub Copilot integration we have done to the Qt Creator helps in many development tasks already today. Copilot understands rather well Qt C++ and QML, and it is also conveniently integrated into our Qt Creator IDE. It reduces the amount of typing that you need and provides better successions than the code completion we offer without AI backend. This has already been available since Creator 11. Hopefully many of you have already tried it out. There are also some challenges in AI coding assistance that we are looking here at Qt. The relevance of the code successions is an issue. We have noticed that when people are working on code for recent versions, sometimes code successions are for older versions, which may not be the current best practice. The content of the OpenAI Codex is sometimes quite old, even with GitHub Copilot taking smaller refreshers from more recent codes. Since software evolves constantly, we need to ensure that code successions are up to date. The second issue we have noticed is related to quality of the successions. It is possible that the succession appears to be correct and fully functional, but contains some hard-to-detect quality issues. Of course, also humans can create code that contains errors, but with generative AI, this may sometimes be really hard to spot. Especially, like Volker said, if you are working with something that you don't know yourself that thoroughly, you use AI to generate the code. If there's a problem, how do you know? Well, Volker knew it didn't compile, so there's certainly something, but what if it compiles but still doesn't do what it should? Third important item to note is the potential copyright and IPR issues. Sometimes the generative AI provides code that is very close to someone's existing implementation. And especially if it provides it in slightly modified form, it can be really hard to detect that it's actually a copy of something. Some models, such as the star-coded LLM, only scan repositories with permissive licenses. OpenAI and GitHub have learned also non-permissive ones. They offer a feature to block code successions from non-permissive licenses, but then if you do that, the code successions often start becoming rather poor. Furthermore, since Qt is an open technology, which is of course beneficial for them to learn, there's an issue that the generative AI vendors at the moment don't offer whitelisting for things that we actually want them to learn. The learning is in their control. It learns what it learns. It's difficult for us to make it learn something. Which brings us finally to the generative AI topics that we are at the moment exploring actively at Qt. We are obviously considering more Copilot options, more coding assistance options to the Qt Creator in addition to the GitHub Copilot that we have now. There are other options out there, and we are investigating how to make them more easily available to our users. The earlier mentioned platformization of Qt Creator will certainly help achieving this. Another item that we are looking is into addressing the challenges mentioned on the previous slide via an LLM trained specifically for Qt and QML. Optimally, we can provide something that is both safe to use from copyright viewpoint and also provide successions matching best practices of Qt development. In addition to leveraging the cloud-based AI, the generative AI that runs on machine rooms, we want to make it easier to harness the edge AI capabilities. This is actually something that Qt is already quite good at, but there's a bit more that we can do. We have already many of our supported hardware boards, especially the embedded boards, the high-end ones, offering edge AI capabilities. And there are also AI functionality provided by different operating systems that we could harness better than today. Exciting times ahead. So, to summarize, I'm really glad to see that the Qt community thrives and we are bringing new developers and businesses into the community. Our open tools and open framework strategy means flexibility for choosing what best fits your needs. The benefits from shift left and test automation help in QA also for AI-generated code. And artificial intelligence in code creation is here to stay, and access to high-quality successions is necessary. Thank you very much for listening.